Today we're going to talk about finding the area under a curve given a starting point and an ending point, and you guys already know how to do this. So why don't you go ahead and write an integral for the area under this curve, which we've called f of x, from a to b. Everybody go ahead and do that right now. And now I'm going to modify this a little bit, and I'm going to add another curve. And I'm going to say that this curve, we'll call it g of x, is going to be added. And now I also want to know the area if we include the area from our x-axis to our g curve. So what I want you to do right now is hit pause and talk with your group and see if you can figure out what the expression for the combined area under those two curves or between the curves would be. So you can see right here that the area between f of x and the x-axis, so this top part, could be represented by this integral. And then the part below the x-axis, which the value of this integral is going to be negative. So you need to take the opposite of it so that your area results in positive. This would be an expression for this region, the area below the x-axis. So essentially, if you add these two things together, you're going to get an expression for the entire area. There's another way you can do this. If you think about adding up all of these infinitely small rectangles from A to B, you're going to get the area. Well, think of it as a strip or a length. That length starts here and goes to here. So if you take the value, the y value here, which is f of x, and subtract the y value here, which is g of x, you're going to get this length. So the length here is f of x minus g of x. And if we add up an infinite number of lengths from a to b, we're going to get an expression as well. So another way to think about this, you could say I want the integral of all of these strips, and each strip is represented by f of x minus g of x. And since we're adding up all the strips in the x direction, we're going from A to B in the x direction, so that's going to be dx. Let's look at another situation. So here I have two curves drawn, and they intersect at this point and this point, and they enclose this area. So if I want to find the area of this enclosed region, I need to figure out how to write an integral to represent that. Now, last time we looked at making strips vertically like this. But if you look at this, there's a problem because over here, I start at the curve and end at the very same curve. So I can't really do vertical strips and add them up in the x direction. But we could do horizontal strips and add them up or stack them in the y direction. And if you look at our horizontal strips, the bigger curve is always the curve further to the right. That's going to be our h of y, and the smaller curve is always the curve to the left is going to be our g of y. So if I want the length of this strip, I'm going to have h of y minus g of y. And notice I don't have h of x and g of x because now we're going to do everything in the y direction. So if I want to stack up an infinite number of these strips, I need an integral that is represented by h of y minus g of y. And since we're stacking things in the y direction, we're going to integrate with respect to y. And I need to figure out where to start and where to stop. So we actually need the y values of these points of intersection. So since we don't actually have functions here, let's just say this is n and this is m. So I'm stacking these infinite number of strips starting at n and going all the way up to m. So this integral would give me a value for the area enclosed by the two curves.